Today I'm going to talk about commit to production and using Kubernetes to facilitate your CI/CD pipeline. How many people here are on the development side? How many people here are on the operations side? All right. Cool. Well, this will definitely be a developer-centric approach to the topic. So starting off with who am I and why should you care what I have to say? I work at Trace3. I'm a principal container engineer there. I do consulting work for Fortune 500 companies and helping them basically build out their container strategy, their CI/CD pipelines, and implement kind of different things within the organization for developer experience. So, a little more about me. Trying not to box myself into a title, but kind of all these things. I put both a geek and a nerd because there's a whole debate between the two, and I really think I'm both, or maybe I just don't understand them. So, as I said today, we're going to cover the CI/CD pipeline. And how many people here are currently using some sort of pipeline in their work? Cool. How many of you are using Jenkins? GitLab? All right. So this will be new for a lot of you guys. So basically, the concept here within DevOps or continuous deployment is this feedback loop. And it's kind of become this moniker, the infinity symbol. Today, I'm going to be taking a look at a small subsection of that and showing how Git should really be your source of truth as you move applications into production. And I'm going to be using a combination, as I said, of GitLab runners, and Kubernetes. And the reason why I did that is because I thought GitLab's Kubernetes plugin was going to make this tech demo really easy to make, and I was wrong. But it's still a good product. So it all starts with Git, and this is something I really believe, and a lot of people have even started calling this GitOps. I don't love that name. It's really come out just because of the separation of the dev and the ops side of DevOps fighting over this stuff. But really, the whole idea here is that a commit and your hash or your tag or your branch represent a point in time. And that point in time should be carried through all the way from when the developer makes that code change to when it reaches production. And any change that is made in between the two adds risk, and it makes the process fragile. We talk, you hear a lot of talks about automation and how it makes things more secure, it makes things better, faster. And really, the main benefit of this is that it eliminates the black box, is that you have something go wrong in production, you can tie it back. This container has this Git hash, goes back to this code change, and I know this is what broke it. The other really important thing, and as I do consulting, I've started to use Git as a leading indicator when I talk to dev and operations teams, is to have a standard. I'm not going to stand up here and tell you Git flow is best, or the new standards that are coming out around hash-based deployments, or any of that stuff are the right answer. It's really just important to have a standard within your organization that people stick to. That allows for there to be a consistent contract between when, as I said, developer commits code to when the next person needs to touch it. The next thing is pull requests. And I know this is a little bit more of a developer audience, so I'm sure most of you guys believe in pull requests, but I talk to a lot of people that are like, I'm the only one editing the code, why do I need a pull request? Even if you're a person of one, you need process. And I have an article I published recently about a time that I, without a process, being the only coder on a team, deleted a production database. So it happens.
Wow.
With an 8-hour time gap on backup. So that was a fun conversation with customers. So today, in order to do this, as I said, we're going to be looking at Kubernetes and GitLab, but we're also going to be using an example Go application. And in true open source fashion, this presentation is actually a mixture of, I think, somewhere between 20 and 30 different tools, but you're not going to see all those. I just want to let you know under the hood. And I will be publishing all of this to a Git repository so you can see where all those tools come from. So let's start looking at the application. We essentially have a very simple Go application. And at the end, I'm going to try to leave some time for questions if you guys want to dig deeper into this. Go is not something I can dig deeper into. I'll try, like ask me a question, but I'm just giving you a word of warning. I try to challenge myself when I do these presentations, and pretty much all the technology, well not all, the Go I hadn't used before and some of this other stuff, because I really want to use these as challenging. So basically, this is a developer favorite Hello World application. I figured I could have thrown up a fancy Angular app, but this will work. And we're going to edit this to show how the continuous deployment works within the project. I also have up a hosted GitLab instance that you guys can see everything to, because basically I'm going to destroy this after today. And I will be putting at some point a way to do this in Vagrant. Right now everything's hosted on Google Cloud, just for convenience sake, which is why I'm really hoping the Wi-Fi doesn't go out halfway through this. So a lot of people talk about CI/CD, and these two get really clumped together. And really what it is it's CI, CD, CD. But that's a lot less sexy. And for some reason, the two terms, as I said, have gotten conflated, but really they represent very different parts of the application stack. CI is tied very closely to your application and is about testing, it's about understanding static code analysis, it's about everything that the developer owns. In the sense that when we talk about that contract between departments or between when a developer commits and the next person takes it over, everything within CI should be the responsibility of the developer, and if anything fails there, it goes back to the developer to fix it. Past that point, it's someone else's problem. But CI should be the developer's responsibility. Then we get into continuous deployment. This really falls on ops. And this is where some of the, we get these tiger teams and these collective groups of DevOps saying, with shared responsibility, which is amazing during transformative times. But at the end of the day, developers, despite what a lot of people say, shouldn't have to learn Kubernetes manifests. They shouldn't have to learn about storage arrays. They shouldn't have to learn about, the difference between layer 3 and layer 4 networking. They can have an understanding of it if they want, but when a deployment goes wrong, when a deployment goes wrong, the person who has that knowledge base should be the one responsible for it. Where if everything is past CI and the deployment goes wrong, you either have a problem with the environment or a systemic problem with CI, which then would go back to the developer. And all this kind of ties together into the concept of continuous delivery, which is really the merger of the two and why I think they've gotten tied together. And continuous delivery is a little bit more conceptual than the other two. This is more about having the quick feedback loop, getting things into production quickly, or more importantly, getting feedback quickly. A lot of people talk about the idea of, well, I don't feel comfortable putting into production quickly. I don't, CI/CD is not for me. But really the point is to get feedback. So if you have CI and CD into a staging environment or any type of environment where you can start getting feedback from a monitoring application, from smoke testing, from anything else, that's what's really important, is getting it out there quickly and identifying risk. All right, so getting into a little bit of the nitty-gritty, what is a GitLab runner? And as you noticed already, I'm not going to read these descriptions. Feel free to, but there's going to be a lot more in the Git repo that I'll be sharing with you guys. GitLab runners really represent the task portion of GitLab. So a couple of you guys said you've used Jenkins. Essentially, GitLab runners are their version of Jenkins X, if you're familiar with that. So how are we going to deploy our runners? A lot of people are used to, in Jenkins, just doing it all on a single host, and that's fine if you're 1 or 2 people, but when you really want to scale, get into microservice, get into high levels of concurrency, you need to figure out a better platform to run your runners on, which is where Docker and Kubernetes come into this equation. Basically, the CI portion of it gets run in a Docker container on your Kubernetes cluster, allowing you to have more efficient parallelization higher compute density and all that fun buzzwords that IT love, but essentially it allows you to have a situation where you're not bound by a single computer. How many people here are familiar with Docker and Kubernetes? How many people here know the difference between Docker and Kubernetes? Okay, so it looks like about half. Just really quickly, this presentation's not about that, but Docker is kind of like I don't want to say VM, but it's an encapsulated runtime environment that is what your scripts, your CI and everything actually run in. And Kubernetes is the air traffic controller that figures out where it gets run, how it gets run, where the logs go, and everything about productionalizing it. Cool. So we're going to start off by showing in GitLab how we would connect Kubernetes to the project I showed you earlier. So they have this really cool GKE integration where to launch a cluster for you. They can give you this whole thing about how they're going to give you credits. And I was super excited about showing this off to you guys, and this is how I was going to do it. And the runner is a version that is 10.3. The one I'm using is 11.3. And the demo I needed to show you fell flat, and I wasted about 8 hours trying to figure out why it wouldn't work yesterday, to realize that I just had to pre-build the cluster. Best laid plans. So instead, you're going to get to see how to connect an existing cluster. And there's a lot of benefit to this too, because you would want to share your cluster across your projects. You wouldn't want a one per. And this will really give you, the economies of scale and benefit of being able to spread your runners across shared resources. So I am going to log into Kubernetes. Nobody steal my password. Even if you did, as I said, I'm going to be destroying this environment, so have fun. And I'll talk through these in 1 second. I just want to get them copied over, and I know it's super fun to watch this. There are scripting ways to do this, but I really wanted to show you guys something in a little bit more of a visual manner. So basically, you need 4 things to connect. There's 5 boxes here, the last one's optional. You need the cluster name, the API URL, the certificate authority, and your user token, which is essentially, for lack of a better term, your API key. Now, how many people here understand certificate authorities in a TLS handshake? All right, 1 person, 2 people, 3 people. That's why developers shouldn't run Kubernetes. Unless it's hosted, but I'm more so talking about large organizations. I don't want anyone to come up after and be like, but I love running Kubernetes. I'm more so talking large organizations, separation of responsibilities for production. Cool. So I think it worked. It doesn't actually give you an error, but you'll see in a second. So the first thing I did before, and I can't run through these again because they've already been run on the cluster. First thing I did was install Helm. How many people have used Helm on Kubernetes? All right, seeing no pattern. Helm is essentially a package manager. I'm sure there's a better term for it, but what it does is it just wraps up all your deployment scripts into an easy command and allows them to be templatized. And the reason why this is here is GitLab heavily uses Helm to deploy your application, to deploy its own things, and that's how it basically templatizes it. The second piece here that's very important to this demo is ingress. And I feel like this term has become somewhat ubiquitous within the container world, but isn't really that well known out of it. So how many people here could describe to me what an ingress is? Yeah. It's Nginx. There's a couple different ways you can use it. It's essentially, if you know the OCI layers, layer 7 routing. In this situation, we're using Nginx, which is the one GitLab recommends. And it allows you to do config-based domain mapping into your cluster. And this is, again, one thing that's really important about this is a lot of people will use these types of environments and go back to old habits and bind things to ports and do things like that, and they end up really losing a lot of the automation benefits. Whereas if you stick to something with an ingress, you can give someone a domain and they don't have to care about, oh, this is port 3845 or anything like that. And you'll see that when we get into the demo. The next one is Prometheus. How many people here have used Prometheus? So it's basically a time-based database. It's used a lot for monitoring. We're not going to go too much into this, but I just wanted to talk about it briefly. This is what the cluster uses for health monitoring. Well, this is what it uses to consume the health monitoring data. So essentially, this all gets fed back into Prometheus, and then there's some really pretty dashboards in GitLab, which we have time I can show you guys if you're interested. The next one is GitLab Runner, which is what we're getting at here. And this is actually installing the container onto Kubernetes. Now this is where it gets a little funky. That will be responsible for creating the containers on Kubernetes for running your code. And there's a little bit of a funky pattern here, and in my opinion, it's a real technical issue in the Docker world right now, because there's not a great way to build or launch containers within containers. I'm guessing if I asked who's run into that, I'll get the same hands. And then the last one, I don't really know much about. I haven't really used Jupyter Notebooks. I'm sure some people in this room have, but I'm not that familiar with it. All right, so the reason why I'm not using the auto GitLab runner, as I mentioned, is because it's running an older version that, in order to do that tricky build Docker in Docker, the special container I'm using to do that doesn't work, which is awesome, and love finding that out when you are trying to get your presentation done for tomorrow. So instead, you guys are actually going to get to see me create it manually. So we're going to go over here, and I have the Kubernetes deployment scripts. And the only one I'm not going to actually show you is this one, which is creating the secret. Not because I'm afraid of showing you guys my password, just because it's a little bit more convoluted. You have to put it into base 64, and it doesn't show well. So the secret portion of it is already included and already deployed. And what that essentially is doing is it is allowing that container that launches containers to have an API key to connect back to GitLab. So the next thing we're going to do is we're going to make a little script because automation. And you can see this is a really complicated one. And all we're doing here, if we look through it, is essentially creating a new namespace and then making that our default namespace for kubectl. Realizing now, kubectl is the CLI interface for Kubernetes that is used to effectively make API calls from the command line. So, in addition to my throat not being great, I don't have great vision, so you guys are going to get the benefit or not benefit, depending, of me zooming in when I do these types of commands. Hopefully it makes it easier for the people in the back and it doesn't make people in the front nauseous. You're in the right folder, or when you run the throat script. So we're going to get an error here because the namespace already exists, and then because I needed to have it for the secret, and then essentially the context is switched to that namespace. So we can look through the Kubernetes. First, we're going to look through the config map, and basically what this is you have, as I mentioned, the secrets, which are sensitive data. You have environment variables, and then one level above that is config maps, which is basically the ability to tie configurations about how things get run or pass things to another container within Kubernetes. It's extremely powerful. We're just going to really scratch the surface today. And basically what I'm doing here is I'm modifying the startup script for that GitLab runner to work the way I want. Very minor things, just having it register, having it connect, and adding in the number of concurrent workers. It's really just for demo purposes. The next one is the deployment itself. And within Kubernetes, you have deployments, you have pods, containers, a lot of things. deployments essentially describe how your pods, which you can think of as your grouped applications, because they can be one or more containers, are, for lack of a better term, deployed. And the benefit of doing it this way is deployments will actually monitor your containers. If your container goes away, it'll relaunch it. If, you know, it basically babysits it as in a declarative state. So it'll, the Kubernetes loop essentially goes through, checks all the deployment scripts, says do these pods exist? If they don't, create them. How many people here are familiar with that concept of kind of declarative infrastructure or declarative? Okay. So essentially, it's a little bit of what I described, or it's, some people call it intent-based. It's the idea that you have a deployment script that instead of running the commands yourself, you say this is what I want it to look like, and then wait for the cluster to make that happen. So I'm not going to go through all of these, but you can see here's the image, which is actually the Docker container being pulled down. And this was another fun one. When I went to do my own, I found out this was on an even older version and had to update it. Yeah, open source. Well, I actually do love open source, but it's just versioning is fun. So you can see down here we're binding some volumes, and here's where it gets a little bit murky with running a container in a container. We're binding the host path of the Docker socket, which is, from a security perspective, a really big no-no, but is kind of, or was, the only way to do this up until a couple months ago, which I'll show you the new way, which doesn't require this. But I just wanted to leave it in there to show you guys where we're going to be using a project called Canico that was put out by Google a few months ago that essentially allows you to build containers in user space without having any type of root access. So going back to here, you can see we're just going to do control kubectl, whatever your preferred pronunciation of that is. Sorry. We're going to do the config map first because the config map will be applied to the deployment, and we don't want the deployment to happen and then have to do it again, essentially. Cool, that was fast. Deceivingly fast. That actually doesn't mean it was deployed. That just means Kubernetes accepted it. So launch that. I guess I didn't make a sacrifice to the live demo, guys. Let's just hope that was the rain on the wind. So basically, the two, they're deployed now, and I can show you. These are all of the pods currently on the cluster. We have a whole bunch of kube system. And this is kind of the dogfooding concept where Kubernetes actually uses its own APIs to run its own workers and everything, which is awesome. And then we have our GitLab managed apps, which you can see we have Tiller, which is essentially the back end of Helm that I was telling you about before, where you have your Helm templates and Tiller makes it happen. It's a good way to think about it. We have our GitLab runner that doesn't work. We have Prometheus, and then our two ingress routers, and you can see they even say Nginx in them. So now what should happen is I go to, in my GitLab instance, all of my runners, and I should see that one registered. And we can see right there that it registered, which is awesome. This means that it was able to connect back, that now GitLab sees this as a shared environment to build out CI. So taking a step back and looking at what we did, we tied Kubernetes to GitLab in 2 distinct ways. The first one was for review applications, which is when we gave it the credentials. And the second way was for the runners. And one was shared across all the cluster, and the actual deployment apps were project specific. And I had to set a domain for it. There's another reason why I did it in advance. We needed to set up some wildcards and stuff like that. And I had a sneaking suspicion you guys didn't want to wait for DNS propagation. So we did it this way. So I talked a lot about that domain-based approach, and what we're going to show is review applications, which are extremely powerful when you're trying to get that feedback quickly. You know, in a lot of environments, when you want to show a demo application, you have to get a VM spun up, or you can run your Ansible script, or even if it's automated, but it's essentially manual work. And what we're going to do here is really powerfully create those review applications immediately when you start a new branch. That way, you're working on this feature, you can share it. So, all of the different what's it called? All the runners and everything we set up should trigger. That's all done by GitLab automatically. So on master right now, we're basically just going to do a quick push and see our application deploy. Anybody have a suggestion what I should change it to instead of hello world?
DVLP.
What did you say?
DVLP.
Oh, okay. On brand. Cool. So we're going to save that. And never commit to production on your local. This is just for demo purposes only. Don't do this at home. So let's just call it demo. Sorry about that. We have a two-factor auth SSH agent. So now if we come over to our runner, or we can go back to our project. Go to CI/CD, go to pipelines. You will see that our new pipeline started running, and you will also see that I've only successfully completed 2 of them before this talk, so it should go great. It works, shouldn't it? And these are the specific pipeline steps that would happen on a master branch. I'll take a step back while this is loading, because this will take, actually this is going way faster than it used to. But I'm still going to go back and show you guys how this is defined in a declarative manner. So of the people here who use Jenkins, how many of you guys use Jenkins files? Cool. Okay. So you guys will get those. Basically, what we're doing is we're describing this is the image to use, and this is one that was a really great helper application that, again, thought was going to be awesome to demo. Got me 50% of the way there. So you're going to see we're actually going to break out of their convention a little bit to use Kenico because it just builds way better. But this is basically a convenience tool built to deploy to Kubernetes from your GitLab runners that consumes all the secrets. Because basically the GitLab runner will inject into the environment everything needed to do these actions, and then you just need your script to pick it up. So here are all of our stages. You can see we have our go build, which is building our artifact. We have our artifact output, which goes into the build library, how long to keep it, the command, and there's no limits on this, so this will run on every push. Build Docker. Same thing. This will build on branch pushes as opposed to tags or anything like that. And this is where we define a separate image for Mechanico that doesn't work with the GitLab automated runner. But it's awesome because, as you can see, we have this nifty script that pulls in all the environment variables, logs into Docker, builds the tarball without needing to have access to the Docker daemon, pushes it, and we're golden, theoretically. So then, the next step that you'll see is the deploy to stage. This config looks a little anticlimactic because that convenience script does so much for you. But essentially what we're saying here is deploy that image with the tag of the current Git commit. Sorry. With the current Git commit and create this new environment of staging with this URL. So the way this pipeline is set up is every commit to master updates stage, and there's a manual push to production. Let's see if that's finished. So it looks like we are on staging. So the magic of pre-production, I already have the URL lined up. And we can see we have the new code already deployed. If we made changes, this would deploy again. But just from that one Git commit to master, it's already in this environment without any intervention, which really frames the responsibility again of the developer of make your code run, make your CI pass, and everything will show up where it's supposed to be. So then we have an example of some manual gating in here as well, with some canary deployments. How many people here know what a canary deployment is? Okay. I don't know if I have enough time to go into that, but it's essentially a way to mitigate risk by having smaller deployments. I'm going to kick these off, and what we're going to do is we're going to create a branch to see how review apps are built. You guys doing all right with the zooming?
Yeah, it's pretty cool actually.
And let's try that again. Hope for the best. Cool. So within this file that I showed you guys before of that GitLab runner, so, this is not the right file. see our review. Our review application. We'll put a branch name and amend it to our Kubernetes host that we defined as a part of our ingress, and that's, I can answer questions about that later, but that's essentially just a wildcard DNS. And then only on branches, like we saw before, and except master, because we don't need a review map on master. So let's go back to our CI/CD. Let's look at our pipelines. We can see it's running. And you can see this one is much shorter. It's only building the container, and then going to our review environment, which this one's taking a little slower. Well, this is working because I'll just show that one at the end. Do you guys have any questions about what I've shown so far? It was easy, everyone already knew it. So essentially what we're doing here is we're just waiting for Docker build.
I've got a question.
Yep.
Well, it looked like when you committed there that it Kubernetes health checks, that it gave you a bunch of options, and that those options were set up in your config file. Was that different deployment options that you can choose to maybe go to stage or to Canary or to different places?
When I push the to Git, or when I push to Kubernetes?
When you committed your change, the Hello Colorado, it just went by really fast.
Oh, I'm sorry. Yeah, those are just the built-in Kubernetes health checks. So that's if you've ever used any load balancer, basically the endpoints that say 200, I'm okay, I'm still alive. And that was just using an example app that had that built in to show it. Did that answer it?
Yeah.
Okay. This is just showing all the environments that have been created. Seeing, it looks like my Wi-Fi is slowing down, and I think I'm about out of time, so I just want to get this one out to show you guys branch-based deploy. Okay, cool. So it is deploying. So while that's happening, what I'll do is I'll just show you guys within the Kubernetes cluster that we have those new pods. Okay, there's a lot now. Basically, up here, you can see in the namespace, these are the review applications and the stuff that I'm showing you guys now. And then the runners are up there too, but they're probably complete. Once this is up, basically, it's just going to show you guys being able to review this at a subdomain of the cluster.com. Oh, there we go. So we should have a new environment here. So we're going to pull the ingress for that one, you'll see. And so as I said, these are just representing basically domain-based configs, as you guys can see. Hello, Colorado. And you can share this around. The only thing else I was going to show, but I think I'm out of time, was opening up a pull request, but it would have just been a repeat of the push to production that I showed earlier. And thank you, and here's some of my other projects if you want to reach out or anything. Any other questions? Okay.
Maybe I missed that at the beginning, but you have a lot of experience with Jenkins pipeline and how much experience with CI/CD support.
Yeah, I do. Jenkins is kind of the, everyone uses it. It's kind of the Kleenex of CI. And it's great, and I like it a lot. GitLab is a little bit more, I think, GUI friendly. Jenkins has tried to do that with their Blue Ocean, and then they tried to also hedge it with being a little bit more developer friendly with Jenkins X. I use Jenkins all the time, and I really like it. This was just an example of having it all in one place. Cool.